Welcome to Lesson 9 in a C# from start to finish course. My name is Tim Corey, and today we're going to wire up our prize form. Now this is a simple form to start with, and it doesn't have many dependencies. Basically, it just takes data that you give it, it makes sure it's correct, and then it saves it to the database or text file. And that is where the first tricky part will come in. How do we know where to save it? Quite frankly, this is where you'll probably get stuck when you're trying to build an application. This is a spot that tutorials try to avoid or try to make sound easy. It isn't easy, but there is hope. We're going to tackle this problem head on because I want to make sure that you can know that you can do the hard things and that they can be made easier if you don't panic and if you break them down into very small pieces. So let's get started. Here we have our prize form. Now, before we do anything, we need to plan out what needs to be done. You should always know what to do before you do it. And this is a great example of why. You see, initially, this form seems simple. When the Create Prize button is clicked, this one right here, we take the data from these 4 fields right here, create the model, and save it. But where do we save it to? The database? A text file? Both? How do we know? Where does that information get set up? How can the code save to both types of storage without being, well, ugly? So let's start off with the ugly way that it might work. And let's just sketch this out in Notepad. And this is going to be a pseudocode just to kind of illustrate the first take at this, the first try at building this form. So pretend we've already done all our validation, because the validation is just simple. It says, is this a number? Is there text in here? Is this a number? And is this a number? And is one of these 0? Okay, that's pretty simple stuff. And we say we've created this model. Remember, we have the prize model here. So we have that model. And let's just call that model, model. Okay? So we have that model, it's populated. Now what do we do with it? Well, we could say, if, and somehow know if we are doing a database using SQL equals true. We have our curly braces here. This is just pseudocode. It's not real syntax. So don't get overly hung up on making sure everything's right. But if we're using SQL, then, open database connection, save the data, and maybe also get back the updated model. Because we want to have, when we create an entry in a database, we get an ID for it. And so we want to have that ID back so we can say, okay, this particular prize is prize number 5 or whatever. So we do those steps and you'd say, okay, but then down here, if using text file, which again, we don't know where using text file or using SQL comes from yet, so we have to figure that out too. If we're doing that, if that's true, then, we do something like this where we'd say, open text file. We need to know the name of it and the path to it and all the rest. Save the data. But first you probably generate an ID, because text files don't create IDs. So we need to have some way of saying, okay, there's 5 records in the text file. The last ID is number 8. Therefore, this is number 9. Whatever it is. Save the data. And so now we've got if we're using SQL, it saves. If we're using a text file, it saves. And then we're done with creating this prize. But this code right here will work. Okay. Now, of course, you have to fill it out with real code. But this idea of a code, this is pseudocode. This would work, but think about all the places where we talk to our database. In every one of those places, we have to have code like this, where we say, if using SQL, if using text file, actually connect to the database. This form has to know what the database is and how to connect to it and all that kind of stuff. And the same thing with text files. It has to know about the text files and where they are and all the rest. But so does the create team form. So does the create tournament form. So does the tournament dashboard form, possibly. And also the tournament viewer form. These all have to know about stuff like this and do this kind of stuff. That's an awful lot of duplicated code, and it's quite frankly pretty ugly. I mean, imagine if we said, okay, we want to change where we're connecting to the database. Well, now you got to change this code right here everywhere. Maybe we say, yeah, we're going to add MySQL as a database option. Oh boy. Every form, we have to now add a third if using MySQL equals true, and so on and so forth. For every form. Multiple places for some forms, because some forms have more than one button. They do more than one thing. So this code isn't really scalable. It's definitely not dry, as in don't repeat yourself. So there's got to be a better way, and we're going to investigate that better way, okay? Because we don't want to write hard to maintain code that's quite frankly ugly and overused. All right? So let's start over. So the method that I use is to keep pulling the thread. Okay, and what I mean by that is I take the issue and start asking questions. And sometimes I just write those questions down. And sometimes I get an idea or a thought and I'll write that thing down too as well. And then I start just keep working at it until I drill all the way down to the bottom of the issue, or to a place where I can say, okay, I can do this step, and then come back and pull that thread again. All right, so this isn't going to be easy because it's not something small. We're not doing just for this form. We're building a system that can be used by every form. What we do here determines what every other form in the database does. So therefore, writing things down and mapping it out means we're less likely to forget a step, and we're very, very clear on what happens. So the first thing we need to do is connect to our data source. So the question I have, and we're going to write this down, is this. How do we get that connection information? Remember in our previous pseudocode example, we weren't even sure where that came from. We just knew we were going to have it. Okay, so that's the first question that gets generated. But then that question leads to the next question is, how do we connect to two different data sources to do the same task? Okay, so part of this system, part of this application is we wanted to have the ability to save to either text files or a database, or both. Okay, and so we want to be able to accommodate that, and really the actual act of saving is the only thing that's different. How we actually put it into a text file or into a database. But from this form's perspective, all we need to do is say, I have a model, save this. And then possibly get a model back that says, okay, we've saved it, and here is the ID along with the rest of the data you saved. Okay, so this form doesn't need to care if we're saving a SQL or if we're saving to a text file, or if down the road we're saving to MySQL. It just needs to care, I'm saving it. So the first question here though, how do we get that connection information? It sounds like we need some type of data that's accessible from everywhere in the application, and it tells us which data source to use. That sounds like a global variable of some type to me. Normally, we try very hard to avoid global variables because they take up memory unnecessarily, but in this case, we need something globally accessible for the lifetime of our application. And that's the exact definition of a global variable. So in this case, I'm thinking about using a static class to hold our data. Normally, again, you wouldn't store data in a static class because it's global information and anyone can change it. But since we want global information, I'm going to need to work on the safety part of the data, but I want to take advantage of the global use. And by making it a static class, I can keep all the global data in one place. So let's write that down. Come down here. These are my questions up here. Down here, I'll have just some notes. So I'm going to say that I want to have a static class for data source info. And this static class is going to tell me which data sources are available. Right now it's SQL or a text file or text files. That's going to tell you that and how to connect to those items. But before we build our class, though, we need to address our second question. How do we connect to two different data sources to do the same task? The key here is we want to do the same thing. Same way. Let's start the interface because we're going to need to do that in order to build a static class. We're going to have that interface. So over here in my tracker library, we want to move all of our code, if possible, into this library. Don't forget that one of our requirements is that we might not always use this WinForms application to track tournaments. We may use other systems like a web-based system. And so the more logic we can put into this library, the easier it will be later to create a new user interface to do the same thing. So in our tracker library, and you could create a folder for this if you want. I'm going to create it right in the root. I'm going to right click on my project and say add, new item, interface. Now, one of the pretty hard and fast conventions for interfaces is they start with a capital I. And that tells you this is an interface. And that's really important when you're actually using an interface. And I'll explain more in a bit, but let's start by just doing an I data connection. So anybody that implements this interface is a data connection, whether it's a SQL connection, a text file connection, or later on down the road, maybe a MySQL connection. And this is an interface. So the first thing I do is make it public. Let me go ahead and change that font to there we go. Let's make this public. So I have public interface iData connection. Now remember, this is a contract. And so in this contract, I'm going to specify what methods, properties, and other items that need to be in here. So in this case, I want just one method. And I'm going to say it's going to return prize model. And it's going to be a create prize method. It's going to take in a prize model called model. So this is a contract for a method. It looks pretty similar to a method, except for the fact we don't have the public in front of it, and we don't have curly braces afterwards, we have this semicolon. And that's because in a contract, in an interface, you only ever have public items. It makes no sense to have hidden contract terms. We don't allow that. We're not sleazy. Everything's up front. Everything is visible. And so therefore, we say since everything is public, nothing is public. Nothing is marked as public because it already is public. So it looks like a method otherwise, except for the fact that there's no curly braces, just a semicolon. And that's because we can't put code in here. This isn't code. This is just saying that whoever implements iDataConnection will have a method called createPrize. The code inside their method may be radically different. It doesn't matter. All we care about is that when you call createPrize and pass in a prize model, you get back a prize model. That's it. So in this case, in the form, when we create this model, and in the createPrize method or event, we say, I want to save this, we're going to call something that implements iDataConnection and say createPrize. We're going to pass in our model, but it won't have an ID populated. When the processing is done, it'll return that same data, only now it will have the ID populated because it's been saved either in the text file or in the database. So that's it. That's our interface. That's our contract. Right now, it's pretty simple because it does one thing. It saves prizes, or it creates prizes. But down the road, we're going to add to this contract as we have to do more things. But for right now, that's all we need to do. So we stop there. Now, let's move on to our static class. So again, I got to right click on Tracker Library and say Add Class. And that just selects the class up here. A static class is like a regular class when you create it. So therefore, let's call this global config. And now we're going to make this a public static class. What that means is you can't instantiate global config. It's always visible for everyone. So if you think of instantiated classes like a blueprint where you create the house off the blueprint, in this case, it's not a blueprint, it's the actual house. And everybody uses the same house, which normally means we wouldn't want to put data in there. But in this case, we actually do because we actually want global data. So let's create a property. We'll create it as a list of iDataConnection. We'll call it connections. Now, two modifications here. First, we need to make this static. So now it's a static property. Next, remember I said that anyone can mess with this. Anyone can set it and change it for the entire application. I don't really want that. So I'm going to say private set. And what this does is it says only methods inside of this global config class can change the value of connections. But everyone can read the value of connections. So how does that help me? Well, I'm going to create a public static void initialize connections. And I'll start off by asking for bool database and a bool text files. All right, so here is where I'll actually initialize the connections. Now you may say, wait, Tim, you created a list of iDataConnection. Why is that? Well, one of the things that I said we're going to do is we have the option of saving, we may save to both a text file or text files and the database, both. And so I created this list of iData connection because we could have one or more data sources to save to and pull from. So that's what this is all about. This initialize connections method is what we're going to call at the very beginning of our application to say, these are the connections I want you to set up. And in this case, I've just had it pass in, do you want a database and do you want text files? Now, right now, this is not scalable, this method. It does two things, a database and text files. But in the future, if you want to scale this out, it'll be very easy to change this method to do something else. Maybe having an array of items, or just to add one more bool MySQL database or something like that. But for now, we're just going to have these two. And it's okay to develop a method to do just what you need to do today. It's just a good idea to keep in mind what might come down the road tomorrow and make sure that you can still adjust if you need to down the road. You don't want to over-engineer your application to the point where it's unwieldy and yet it does one little thing, okay? But on the other end of the scale, you don't want to build your application just for today with no thought about tomorrow, because tomorrow the boss will probably come to you and say, I need it to do these extra things, and it makes your life miserable to try and redo it. So just think down the road and make sure that you're at least keeping in mind potential upgrades or changes for the future. So we have two Booleans passed in, a database and text files. What that's going to allow us to do is say if database. Now I could say if database double equals true. And that's more explicit. And if it helps you understand how things work, this is fine. This is definitely okay. But whenever you have a Boolean value, you don't have to do a comparison because it already is a Boolean value. Whatever's inside these parens has to finally get to a true or a false value. That's why we have the equals and not equals and greater than and less than. Because if we say I is greater than 0, the result is either true or false. But in this case, this variable is already only true or false. So in this case, if database, so if we're going to use a SQL database, then do something. Let's come down here and say if text files, do something. So a couple notes here. First of all, I didn't really do anything. I left a comment that says, do something with this. And in fact, what I would do is actually make this a to-do. Okay, and a to-do list will show up in your task list. See the task list down here? If you don't have that, go to your view, and the task list is right video to see how it works. Don't stress out about it, just watch it. Try and pay attention, try and follow along. But then go back to the beginning, watch it again. This time, pause the video every time I do something and do it along with me. Knowing the end result can help you understand what's going on, and repeatedly watching will help reinforce what you're learning as you create it alongside me. Now, it also means the first time you watch this, you probably shouldn't be building it along with me unless you're really tracking. And the reason why is because sometimes typing will distract you from what I've said and you kind of miss things. So I'd recommend, if you're at all unsure the first time, don't type anything, just watch. Then go back and type a second time. All right? So that's just my aside. Don't freak out. I've done this for years. I know I can get you through this. So now that we have a static class, right? Well, here. Okay. So now we have a static class that holds our connection interface. And it has make it public. And here's the interesting thing about this one. We're actually going to say colon after the class name and say data connection. Now it's going to yell at me right away. And the reason why it yells at me is because we have not followed the contract. We said we're going to use this contract, data connection. But there is no method in here called create prize. So what do we do? Well, if we select this, we can either use this drop down here or hit Control Dot. And there's this implement interface. So if we do that, and notice there's explicit interface and implement interface. Do the first one, implement interface. And what this does is it creates a new method called create prize. It returns a prize model and it takes in a prize model called model. Sound familiar? Well, this right here is this right here. So it said, okay, you got a contract here. Here's what the contract says you're going to do. Therefore, you can go ahead and create this method to do exactly that. Now, you could hand code this if you want, but it's pretty easy to just to say implement the contract. And the great thing is, as the contract changes, let's just pretend I add another contract entry here. Let's just do that. I'm going to copy this just to show you what will happen. We'll create a create prize 2. It's a horrible thing to do, but we're going to do it. We come back over here, and data contract connection. It's going to yell at us again. And it says, you're not following the contract. You're partly following the contract, but not the whole contract. And the way contracts work is you have to follow the whole contract. But if I do my Control Dot here and say implement interface, notice it only adds the extra method that I need. It doesn't touch the first method because it already has that method. It just says, what are the differences? What parts of the contract haven't you implemented? And I'll add those. So that's really nice. Let's take this back out. I'll save that. Now note, it's not yelling at me now because the contract is covered. I still have that create prize method. And I have this extra method now called create prize2, which isn't in the contract, but yet it's in this class. And that's okay. You can have extra stuff in this class. You just have to make sure you at least have the contract stuff. So I don't really need this. I'm going to delete this. The other thing I note is this throw new not implemented exception. And this is brilliant. Microsoft has said, we create some code for you, but we don't want you to pretend like this code really works. But at the same time, we don't want to give you red squigglies. So what they said is, this method returns a prize model. They're not going to scaffold out a prize model and pretend to return it. Instead, they throw a new not implemented exception. So this code will compile. There's no red squigglies. But if I were to call this method, the first line it hits is going to throw an exception. And that exception is not implemented, meaning I haven't actually put code in here. This is a dummy method. And so that's a brilliant way for the system to have this method and yet at the same time not pretend like it's real code. But in our case, we're going to make a modification to this. We have to return a prize model, but we get a prize model in. So let's start by saying model dot. Now there's no ID yet, but we want that ID because in the database, and let's go there. In the database, if we go to the table for prizes, we see there's an ID. And you want to capture that because that's what uniquely identifies a prize. So therefore, let's go back to our model, our prize model. And up here, I'm going to say prop int ID. All right, and that's the unique identifier for the prize. So now we have a new property. So I do Control J here to bring that list back up. I see ID. So ID equals, let's just say 1 for now. That's our sample number. Then we can return model. So now this method actually does something. Now, does it go out to SQL and save things? No. It just pretends like it did. And in this case, what I would do is come here. Oops. Yes, I should put my code comments, and let's just do that. All right, so there's my / comments, and those are great to have because it describes what your method does. That way, later on, you say, create prize, what does that do? Well, it saves a new prize to the database. But I'm also going to add up here a to-do. Make the create prize method actually saves to the database. Okay, and now I have in my task list yet another to do. Now you could say, well, but go ahead and actually do that. Make it save the database. I'm not going to do that because I'm already down a rabbit trail pretty far. Because remember, the original intent for us for this lesson was to wire up this form. And we haven't even looked at code behind this form. We've talked about it. We haven't even started there. Because first we created, our static class, and then we created our interface, and now we're creating a class. We still have one more to create. So that's a lot of stuff to do when really we're just trying to save our prize. So I'm not going to implement any more code than this. But now let's go and add the text file connector. All right, so right click on Tracker Library, add class, and we're going to say text connector for the name. And that is a class. We'll make this public. And we're going to implement, using the colon, I data connection. And again, control dot implement interface, which looks eerily familiar to our SQL connector. Now, before we go on, I also want to mention the reason why we put I in front of interfaces. And this goes back to object-oriented, because right now this is just a contract, and you can have tons of contracts on one class. In fact, if we wanted to, I could say I disposable, and then add that interface, and that just adds one more method. So now I have two contracts on this one class. This contract says you must have a dispose method. This contract says you must have a create prize method. So we can have both of those if we want. But if we want to actually inherit from a class, which means we don't just bring a contract, we actually bring code with us from a class, we can only do that once. We can only inherit from one class. And so when you're inheriting, the first item here has to be what you're inheriting from before any contracts. But in this case, if I didn't call this I data connection, how would I know if this is my class I'm inheriting from or if it's a contract? The only way I know is to mouse over this and say, oh, yep, it's an interface, which only works if you're actually in this IDE inside Visual Studio. But if you're looking at this in a text document, that doesn't work. So it just makes it a lot more clear if you have this I in front of it. Every interface will have an I in front of it. That's very clear then to know this is an interface. Now, if the class you're inheriting from starts with I, say the class name is Indiana. Maybe not the best class name, but it starts with an I. The difference will be obvious. And the reason why, let's type it out. Now, I don't actually have a class called Indiana, but notice my casing here. The N is lowercase. This D is not. You see the difference? That's how you can tell an interface from an actual class name, even if they both start with I. And that's why casing is important. All right, that's way off the rabbit trail. I just want to make sure that you really grasp that. And again, I have a video on interfaces on my YouTube channel. But here, we're going to do kind of the same thing as what we did in SQL Connector. In fact, we're just going to grab that code and do the same thing. Copy and paste. Now, saving to a text file is radically different than saving to a SQL database. But at this point, we're just doing sample. We're just saying, pretend like we actually saved it. So in that case, we don't need to worry about, differences. We're just saying, pretend like it works. And then I'll add my to-do here. So that I actually have a reminder to come back and actually do this, since this is sample code and not just that throw new not implement exception. And the reason why I did that is because I actually want to use this code just to show that it will work. Okay? So now we have both of our real classes, our full classes created. Now they're pretty simple, basic stuff, but we can come back to our global config, and here we can actually wire up our classes. So if it's a database, we're going to say we want to create a SQL connector, and let's call it SQL equals new SQL connector. And then we'll say connections dot add SQL. Now, this is going to break, and here's why. This list has not been initialized, but one of the perks of C# 6.0 is I can say equals new list of iData connection right in my property list right here. Now, if you're using a version of C# before the C# 6.0 came out, which it's really vague how Microsoft does this. It's very hard to find out what the C# version is versus the .NET version is and where they all fit. But essentially, if you're not using .NET 4.6, which I believe is Visual Studio 2015, if you're not using that, you can't do this. But never fear. If you can't do that, in your initialized connections, before you do anything else, just say connections equals new list of connection. It'll do the same thing. Okay? So you can do that if your code won't accept this. But this is a new way of doing things. So now I have created the connector and have added it to my connections list. I'm going to change my to-do here to set up the SQL connector properly, because there may be some initialization stuff that I need to do on that class that I can't do yet because I don't have any initialization stuff yet. So let's just make sure that we check that out at some point. We come back to that. And we'll come back to that in actually the next video. But for now, this works. Now I took SQL connector, that's the class type, I create an instance of that, and I added it to my connections list. But my connections list isn't a list of SQL connector. It's a list of iData connection. That's the interface. And so what this list does is it says, I'll hold anything that implements the iData connection contract, which is amazing because they don't care if it's a SQL So you can't do this. Else if. That won't work because you'll get unexpected results. You'll only add a text file if you don't have a SQL database. Which, if you're saying, well, I only ever want to have one connection, then yeah, that's how you do it. That's one way of doing it. But that's not what we want. We want to have the option of having one, the other, or both. In this case, it's two if statements. Now, the final piece to all of this is determining when to call this initialized connections. Because remember, This is when we actually set up, do we have SQL? Do we have a text file? So we should do that when the application starts. Now down the road, we may say, well, I want to change how that works. But for now, we know where the application starts. Down here in program.cs, this is where our form application actually launches from, the static void main. So we have 3 lines of code that Microsoft has created. Application.enable visual styles, application.set compatible text rendering default, and application.run new tournament dashboard form. This is where we determine which form gets launched as the startup form. Now this is going to be the startup form that we use for our application when it's finally done. This is the real startup form. But I want to modify that form in just a minute to actually point to my create prize form because I want to just see that in action. I want to see it working. So we're going to change this line in a few minutes. But for now, before this line, I want to add this code. So I'm going to start by putting a comment that says initialize the database connections. And I'm going to say my class name, tracker library. And I don't think I have a reference to that. So let's right click on references, add reference. Go to projects, tracker library. Notice it says library. So I can feel free to check this box. That's my convention, but it's a way of making sure that you don't add the reference the wrong direction. You don't want to add a reference to your form in your tracker library. You want to add a reference to your library while you're in your form. So we hit OK. Tracker library dot global config dot initialize connections. And now we're going to say, do you have a database and do you have a text file? I'm going to say true, true. For now, let's initialize with everything. Now that this is initialized, everybody can use that global information because it's global. So when tournament dashboard form would load, it would have access to the connection information. But I'm actually going to change this to say that I want to start up my create prize form instead because I want to see this working when I actually wire up that form. So I'm going to copy this line because this is the line that I want eventually. And instead, I'm going to add my own line that is create prize form. So now, instead of the tournament dashboard form launching, when the application runs, it will launch the create prize form. All right, in fact, we can start now and make sure that at least it compiles and it runs. And sure enough, the create prize form started. So now we can actually get back to our create prize form and actually wire it up. Amazing. It only took us like 50 minutes to get here. But that's how coding works. You really need to think things through, make your plans, and then implement them in that order in order to safely create your code. Otherwise, you create that weird junky code that I talked about at the very beginning, that pseudocode that I created, that really doesn't work. All right? It doesn't work for scale. It doesn't work for maintaining it. It just isn't great. So again, let's come back now to our prize form. We're actually going to double click on this create prize button to launch this event. All right, so create this event called create prize button _ click. So whenever we click this button, then this code will run. Now, what do we do here? Well, here, the first thing we need to do, let's close these other items. Yes, I'll save this. I'm actually going to open that form back up. All right, so we're going to validate these 4 fields first. That's the first thing we'll do. I'm actually going to create a private method. You don't have to do this, but I like to keep my events clean. So private void, let's do a private bool. Private bool validate form. Now this validate form, we can run from anywhere. It doesn't have to be just when you click this button. So you could validate this form after this last field is filled out. And so this way, it just is on its own. We can call it from here and say, oh, you weren't valid. You returned false is not valid. Therefore, stop the process. So we return bool. So actually create a bool output equals false. Return bool. Output. So what do I do there? Well, I like to create this variable called output. And that output variable is what I'm going to return. In my case, I'm actually going to set this to be true. Now, I would love to set it to false, and then whenever I returned it, the form would be by default not valid. But it's just so much easier to say no, something is not right and set this to false than it is to say everything is right, set it to true. And I'll show you what I mean by that. So this first field right here is the place number, and this needs to be an int, meaning a whole number, and it has to be 1 or greater. All right. So we can say, let's start with this: if int dot try parse. The string is our placeholder, our text field right here. So place number. So place number value dot text. Because remember, these are text boxes, not number boxes. Therefore, this is a text value, not a number value. So we gotta do a try parse. We need to give an out int result. Okay. So this out int result will be what we change the value to a number. So we have to create an int variable here. Let's call it int place number equals 0. And then we'll say right here, out place number. Now what this does, let's actually break this down into 2 lines, just to make it a little clearer. So Control X and cut that. Bool place number valid number equals our int.tryparse. So int.tryparse, what it does is it takes a string. In this case, our place number value.text, the value of this text box right here. It takes that string and it tries to make it into an int. So say that value is the number 1. Then it will try to convert that. It'll say, yep, that converts. It will put that into the place number variable. Now this is an out. What that means is we can only return 1 value from our try parse method. And so it says, I'm going to return a Boolean saying if this worked or not. But I also want to return the value, the actual number. Therefore, I'll do an out parameter. An out parameter goes the opposite direction. Instead of passing data into this method, we're passing information out. So I have to say it's an out parameter, and I have to say a name of a variable to store the information. If that's a little confusing, don't worry. We don't use out parameters anywhere else except for try parse. And in fact, in C#7, which is Visual Studio 2017, we actually can change this and not use out parameters and instead return what's called a tuple, which is 2 values instead of just the 1 return value. But we're not getting into that today. We're not going to worry about covering that yet. I want to cover what works now and will work in 2017 as well. So in this case, we're going to return back a number here, which we really don't care about. We just care about whether or not this try parse worked. Because you see, if this text would be the text ONE, which we all know that ONE translates, into 1, and that would represent a number. But when it comes to programs, they don't know that. And so they're saying it's not the actual number 1, it's a text. Therefore, this parse isn't going to work. But it's a try parse. And so a try parse doesn't crash when you get bad information. Instead, it returns a 0 here, and it says the actual method returns a false, saying, nope, it didn't work. So now I can take this Boolean value and put it right in the if statement. If place number valid number. So, but I don't really care about it being a valid number. I want to know if it's invalid. Because if it's an invalid number, I change this to be false. Now I could say bang place number valid number. And what that means is if not place number valid number, meaning if this is an invalid number, then do this. But that can be a little confusing, especially for new users. The other way you could do it would be to say double equals false. If the place number is not a valid number, then do this code. And one of the things we'll do is we'll say output equals false. Now, one trick here is do not put an else statement here. Do not say else output equals true, because this is only one of many checks. If the last check in line is valid, it would set the output to true, and then the whole form is valid. But that's not really how it works. Instead, we only set it to false if something fails. We don't ever set it to true because it's already true up here. So that's our first check. Checking to see if it's a valid number. If it's an invalid number, set the output to false. But the next check, if place number, that's the actual number that came out, is less than 1. Because remember, you can't have a place of 0 or -1 or so on and so forth. Output equals false. So if it's a valid number, but that number is -1, it's not a valid form. Now we can go on and validate the other items as well. The place name needs to have an actual name. So therefore, if place name value dot text dot length equals 0. Basically, if you have nothing in the place name value, then output equals false. Now, in all of these, you could put some kind of logging statements, or update the form. Maybe have an area somewhere, maybe over here or down below or something like that has all these error messages. And each time you get an output equals false, you would set an error message right here that says the place number is not a valid number, the place number is less than 1, the place name is empty. You could add those statements and then add it to some kind of form or field in your form. But in this case, I'm just going to say valid or not. All right, so in this case, we've done these first two fields, and then we have to have prize amount or prize percentage to be greater than 0. One of them does. All right, so we're going to do the same thing, but remember that the prize percentage is going to be a whole number because we're saying, okay, it's 15. If value is 15 here, that's 15%. Whereas this one here, prize amount, could be is a decimal. All right, so it's money. So we're talking about $30.15. Why? I don't know why. You'd think you'd want a whole number there, like 100, 200, 50, 10, whatever it is. But we have to allow for the fact that they might want to say, no, I want to give you $9.50, not $10. So therefore, the prize amount has to be a decimal. So let's create a spot for that. So we'll say decimal prize amount equals 0, and the other one, which is prize percentage, is a whole number. So int prize percentage. Now it could be a double if you're going to allow for 15.5%. But we're going to say no. You have to have a whole number here. We're going to say equals 0 again. And now we're going to do the same kind of thing we did up here with our conversion. So let's move this down a little bit. Let's say bool prize amount valid equals, and this is a decimal, try parse. It works the same way as the int try parse, it just converts to a decimal. And we're just going to say that the prize amount value, dot text is our string, and then out prize amount, that's our decimal that we're going to send this value to. And we'll do the same exact thing, bool prize percentage valid equals int dot try parse. We're going to say this is the, not price percentage, it's prize percentage. It's prize percentage value dot text and out prize percentage. All right, so make sure you get the decimal here and the int here, because that's what we're returning these values as. So that's important to get right. But now you can come here and say if prize amount equals false, prize amount valid equals false, or prize percentage valid equals false. And the reason you do both is because both of these should have a number in them. They should start at 0, but one of these has to have a valid number in it. So they both have to be a valid number, meaning they both have to have at least a 0 in them. So therefore, if either one is invalid, then output equals false. But then we're going to say if prize amount is less than or equal to 0 and prize percentage is less than or equal to 0. So what this is going to do is say, we could just say if they're both equal to 0, but that doesn't capture it, because what if one of them is below 0? That would trigger a this is okay. But really, they have to be both, one of them has to be above 0. So this is saying if this one is at or below 0 and this one is at or below 0, they can't both be that. So if they both are, then output equals false. All right. And now we could do some more checks since we wanted to. One of the checks we could do is if the prize percentage is between 0 and 100, because it could be 0 if we're using the prize amount. But let's just do that. If prize percentage is less than 0 or prize percentage is greater than 100. Okay, remember a percentage has to be between 0 and 100. You can't have anything above 100%. So, if the tournament brings in $1,000 and you're saying, I want to give them 150%, well, that would mean that you are going to lose $500 on this tournament. That's got to come from somewhere. So basically we're saying, no, you can't allow that. So therefore, output equals false. So that's if the prize percentage is below 0 or if it's above 100. All right, so that's our validation. That whole code right there. We'll save that. So now we're going to say if validate form. So if it's a valid form, remember this returns true or false. Oh, and one more thing I want to note here. You could, instead of having the output variable and all the rest, you could just return false here, return false here. And the very bottom, return true. Some people will say that's better because it doesn't do all these other checks if the first one fails. The reason I did it this way is because that way it does all the checks. In a real application, you'd want to alert the user that they did something wrong. And here's what you did wrong. That's why I said, right here you could say that it's not a valid place number. You could put that in the form or something like that. And you do that for all the places where you say input equals false. So if you did that and you did the return false up here, you'd only check the first thing. So if this form were entirely invalid and they hit create prize, they get one message back saying, hey, change the place number. They do that, hit create prize, and get a different message back. They fix that, do that, they get another message back, and that'd be annoying. Whereas if they hit create prize and nothing is valid, they'd get all 5 or 6 messages at once. They could fix everything and then run it. So that's just a little quirk there. You may see it a little differently in other places, but that's why I did it that way. Now I don't have those messages. It's just set up for those messages when I'm ready. All right, so in the prize button, click. If the form is valid, then we need to do something. Well, we need to create a model. And what model is that? The prize model. And it's right now yelling at me because it doesn't see a prize model. Well, I hit Control Dot and say Use Tracker Library. And now it knows about it. So let's just call this model equals new prize model. And we can say model dot place name equals place name text, or I'm sorry, value dot text. Then model dot place number equals place number value dot text. And right away we have a problem because that's not valid. That's a string, but place number is an int. All right, so there's two ways we can go about fixing this. One way is we can do this try parse again. We can try parse the place number and also the prize amount and the prize percentage. That's a lot of work right in here. Or I can come to a prize model and I can come down here and I can create a constructor. Now this constructor is an empty constructor. And what it does is essentially nothing right now. It takes nothing in and it just says, do this code, whatever this is inside curly braces, which is nothing. That's cool. We actually want that because that allows us to do stuff like this. That's calling that empty constructor. Notice the no parameters. But now I want to do CTOR again. CTOR. And it creates another constructor. And it yells at me and says, you can't do that. But we can create an overloaded constructor. And that overloaded constructor says string place name, string place number, string prize amount, and string prize percentage. Now notice they're all strings, not numbers. And what this allows me to do is I can create this prize model on the fly and populate it and do all the parsing here once. And then anywhere that calls it can call this method and have the stuff parsed. So the simple one, place name, capital P, it's important, equals place name. So I'm taking this parameter and putting it into this property. So that's the easy one. But now we need to do all those other parses. So int place number value equals 0. And then we're going to do int dot try parse. And we'll say the place number, that's the string being passed in, that's our string. And then out place number value, that's the string we're storing it in. And then we'll say, in fact, let's tighten this up so we'll have it all in one grouping. We're going to say place number, the actual property, place number, equals place number value. Now, I can check to see if this passed or failed. Why? Well, because I don't really care. At the end of the day, all I care about is a safe parse, meaning it doesn't blow up if you give me a string that's not a number. But if you give me an invalid string, I'm going to change place number to be 0. Because that's what the default is when it comes out of try parse if it's invalid. So I'm going to set to 0, which, guess what? That's the default for an int anyway. So I'm going to say, don't care about it. Just do it. All right? So let's do this again for our prize amount. Now, prize amount is a decimal. So decimal prize amount value equals 0. Decimal dot try parse place amount, prize amount. There we go, prize amount. And then out prize amount value. And then finally, prize amount equals prize amount value. So it's the same thing all over again, just for the prize amount. And then finally, I have the prize percentage, which the prize percentage is actually a double. Let's go back and fix this over here. Because here we said it was an int, all right, for the prize percentage. So let's just change this to be a double. And the prize percentage here, double. All right, works the same way. It's just now we're using double instead of an int. Okay, so back over here, we're going to say double prize percentage value equals 0. Double dot try parse prize percentage. And then out prize percentage value. zoom in on that for a minute. So if we do this, we get one of two. That's because we either have the default constructor or this constructor. Now I left the default constructor because I want to have the ability to just say, nope, new prize model, I'll take care of populating the properties on my own. But in this case, I can pass in those 4 properties. So let's do that. Place name value.text. Next is the place number value.text. Next is the prize amount value.text. And the final one is prize percentage value.text. Notice how it scrolls off my page now. The way you can fix that is before the first parameter, you can hit enter, and then every parameter afterwards do the same thing. And now it's kind of a collapsed or a shortened version of it. It makes a little more visual sense. It's easier to read. So that's up to you. So now we're creating this new prize model, and it's immediately populating with the values we need without having to do all that conversion on our side. So now we have this, what's next? Well, once we have a model, we actually have to save it. So here's how we save our model. We say for each, we can say var here if we want, or we can say the actual data connection. It's up to you. I'll just say db for the name. We're going to say global config dot connections. And what is that? It's a list of those connections. It's a list of data connection. So for each one of those that we have, we're going to say db dot. Now look at my options. In fact, let's zoom in on those options. I have the standard equals get hash code, get type, and toString, but then I have one method called create prize. What does that pass in? A model, which I already have. What does it return? A new model. So what I can do with that model is I can save that if I want to, or I can just ignore it. In this case, I don't need it at this point. Maybe later I will, but for now, I don't need it. And guess what? We actually have a completed form. But are we sure it's complete? Are we sure that all that code he wrote is going to work? And I really get uncomfortable when I start writing, 50, 100, 200 lines of code without testing it. So the way to test it, we can put a breakpoint right here, the very beginning of our create prize button. Click and hit start. And that pops up our form. The very first thing I'm going to do is hit create prize. Well, it goes there. That's good. Now it's going to validate form. So let's step into, or F11. And it's going to come down to our validate form method. We can keep stepping through this. We can say the first one is try parse for our number value dot text, which is nothing. And if we step into again, we can inspect this now and see that the place number value is invalid, it's false. Therefore, we're going to return output false. The place number is 0, so it's less than 1, it's false. The place name value dot text dot length is 0, therefore output is false. And we can keep going if you want to, but I'll just put a breakpoint down here and say continue to that point, hitting the green button, and then I'll step again and come back here, and it just exits out. That's all it does. So we'd probably want to add some kind of message there that says, hey, it's an invalid form. Let's actually do that, just a real quick one. Hit stop right now. Just a real quick one. So let's take our breakpoints out. And this time we're going to say, if it's not a valid form, else, and let's just do a very simple message box dot show this form has invalid information. Please check it and try again. And we could make that a little more fancy with the buttons we have and all the rest, but let's just do just that. If we launch this again, I'll move it back over to where it was. I hit create prize, and nope, it's invalid. Okay. We can come back over here though and put our breakpoint inside of the valid form. Now let's go back and put a place number, first place. The amount, the prize amount is $50. That's going to be 0 for prize percentage. Remember, the 0 is the one we ignore, but you have to have a number there. We create prize, and hey, it's valid because it got to this line right here. Let's step into this, and notice it comes down to this constructor. We can say, all right, check that out. Place name is first place. That's good. We can do a try parse, and that seems to work because place number is 1. The prize amount is 50. That's good. And the prize percentage is 0. Great. And in fact, if we step to the next line, we can mouse over our model and see that all of that information has been entered. The ID is still 0. So now for each iDataConnection DB in global config.connections, let's go into this. First, you can mouse over this and see that there's 2 connections, the text connection and the SQL connection. So that's great. We actually have something. So for the first one, which if we mouse over DB, it's the SQL connector, we're going to create that prize model. We're passing in our model. When it comes right to our SQL connector, and notice we're modifying the ID to be 1 now, and returning that model. Now we're not doing anything to that model, but at least we know that it actually pretended like it went to the database and saved it. Now we're looping through the next one, and that's our text connection. And again, we run this, and it goes to the text connection class, and it calls the create prize to actually save this model. Now it's not actually doing anything, but that's okay. And we're done. So if we hit continue, this form is now working. Now there's a couple of tweaks you want to make to it before we're done. One tweak is when you're all done creating a valid form, you actually create it, then go ahead and wipe out these values. The other thing I want to do is I want to add that these 2 fields start off with a value of 0. That way you don't have to add 0 to the other field. So that last one's easy. We'll go to our properties for that text file or a text box. And for the text, we'll put 0. And down here, the text, we're going to put 0. And that's it. That's our properties are now set. The other one is to clear out that form. Well, if it's a valid form, you don't want to clear it out if it's invalid form. We're going to say these 4 values. And let's just grab these and actually copy them. And paste them down here. We got to take the commas out. And it's going to yell at us for a bit. And that's okay. We can move them back. We can say equals empty string and a semicolon. We can do that there. These last 2, we don't really want to say empty string. We want to say that it's a string with 0 in it, the prize amount and the prize percentage, because again, the default value for price amount and price percentage is 0. Now if we run this, and we won't put a breakpoint this time, so let's make sure that's cleared, and it is. So now we can say it's second place. The price percentage is, let's leave them both 0 for a minute. Oh, it's invalid. Okay, price percentage is -15. Nope, still invalid. Oh, it's +15. Yep, that worked and it cleared our form. All right. So that's a lot of work, but at the same time, now we're done. Now we've got this form created and we've got a pattern for how to save to a database, a text file or text files, or both. Okay, so that's all taken care of for us. So that's great. Now we need to move on to actually wiring up those classes. So we have the SQL connector class, and we have SQL connector class and the text connection class. We need to wire those up to actually do the work. So in our next video, we're going to start off by doing our SQL connector and actually talking to our SQL database. So don't forget to stay tuned for that.